All right, welcome one and all. This is a quick review over Java 1, basically Java 1 in a single sitting. So we're just basically going to review over the entirety of Java 1. So first and foremost, probably need my magnifier, and that's not what I wanted to happen. Magnifier, why in the world did you pop up like that? And an edge, good lord, go away. All right, there we go. All right then. So effectively what we're going to do is just, again, go over Java 1. So very quickly, system.out.println. We're going to use NetBeans. Now for those who may not have had me before, I'm going to tell you a few things I want you to do that you may not have had to do before. First off, I did not name mine correctly. I called it Java 1 Review. But how I would normally name it looks like this. And actually there should be a little underscore there. It would be underscore and whatever the date happens to be. I am, of course, doing this like 200 years in the future, as you can see. And then I put the name. And the reason I do this is because whenever I'm doing the projects, it keeps them kind of in chronological order. It makes it easier for me to search for them. If you miss a day or something, I can tell you, well, I did that on, Tuesday or on the 5th or something like that. And it makes it easier to find those projects. So I usually name it with the date in front and then the name afterwards, just to keep it in order. You can name it however you want. I just find this makes it a little bit easier to sort. Now, the other thing I do, and I would encourage you to do this, is when you first make a project, you usually get this kind of default setup here. The void main, you've got, of course, these two braces at the end. Now notice I've got two comments here, \\, in main, because this ends the main, \\, in class, because that ends the class brace. I put little comments at the end of the braces because, especially in Java 2, we're going to have a lot of these braces. And I just find that helps me keep track of everything. More likely than not, errors end up being brace errors a lot of the time. If I have some extras, I can click here and say, well, that doesn't end what that's supposed to end. And maybe I can come in here and, that'll help me narrow down the issues. So I would encourage you to do this because honestly, I've had my students do this. I think it was like the third or fourth year I was teaching maybe. Everyone was just having all these brace issues. And I'm like, okay, everybody do this. And it was such a dramatic improvement. Everyone that was having brace issues had significantly less problems. People have gone on to Ole Miss, Mississippi State, and other colleges, and they told me that other people weren't doing this and they were having those problems while they weren't. So I stand by this. I think this helps greatly. One teacher actually told one of the students that that's useless. Why are you doing that? It's just a waste of time. And they were the only student that didn't have brace issues in that class. So it kind of proved the point that I think this helps a lot. It really takes you like a second to type this out. But every time I have a brace, I usually type end, if, end main, whatever. I put a little comment there so I know what it's supposed to end. Now, to our basic stuff, system.out.println is our basic print statement. Hi there. You can use the shortcut in NetBeans, SOUT tab, and it'll fill out that whole thing for you. Blah, blah, like so. You can also add numbers if you want to do that. Tab. 5 plus 4. Well, plus 4. And I can run it by pressing F6 or clicking the little arrow button at the top. But you see, it'll actually do the math. Now, I can also, add the math to the end of a quote. There's a couple of different things I can do. I can come up here and say plus, 4. And you'll see it says blah 4, and it will appear exactly as it appears. There's no space, so it just adds the 4 to the end. If I add a space, you'll see the 4 get a little space in between too. If I want to do math, then most likely I will have to put some parentheses in here, like that. 4 plus 4 is 8. That's your basic print statement. If you want to use what's called the JOption pane, then you're going to have to import java.util. Oh, actually, I'm sorry. I'm doing the scanner. JavaX dot. Let me see if I can remember this. JavaX.swing.jOption pane. There it is. And this allows me to use pop-up boxes instead. Now, whichever you prefer, it's entirely up to you. Honestly, I think the print statements are easier to use for the most part, but if you prefer the pop-up boxes, you can use those instead. And to display a pop-up box, this is output with print statements. And there are other print statements like system.out.print, before I get to that, which if I do this, hi there, and then I do another print statement. Copy and paste, by the way, is your best friend. Copy, paste, hi there. It'll put them on the same line. Basically, print line will print this thing and press enter. Print, press enter, and there's the cursor. It prints the next one, presses enter. Prints the next one, presses enter. Print prints it and keeps the cursor right at the end. Prints it and keeps the cursor right at the end, as you can see. Now I can put a /n in the quotes, and it will basically be the same as enter inside the quotes. I could also do a plus quotation mark /n, and it basically has the same effect. It just gives me an extra space. Now for the JOption pane, and there's also printf, which I'll probably get into later. You can look it up, but it's another way to print, and it actually has some formatting options in there, which are kind of cool. But printf, I'll just make a little comment there. Printf, look that up. So Java swing JOption pane. JOption, and that's capital J, capital O, capital P, dot show. And notice as I hit period, we get this whole list of things. There's confirm, input dialog. I'm looking for show message dialog, and there's a couple of them. I'm just going to pick the top one. The other one has a couple of other options where you can choose icons and various other things, but I'm going to use the simplest. This first component, just write in null. Basically, that kind of asks who owns this window. I'm going to say nobody owns it. So, and the args are what's going to appear on the screen. So, in this case, let's go with chicken sandwich. I run, and lo and behold, I get a pop-up message called chicken sandwich, and all the other stuff gets displayed on the screen beforehand, as you can see. I hit OK, and the program finishes that and ends. So JOption panes are nice. You can do the same thing you've done here, where we plus and add more stuff if you want. You can use variables and print those and stuff instead. Now, if you want to use one of the other options, JOption pane dot show message dialog. Let's say I pick this second option here. Notice I still get the component thing there. I'm just going to make that null. The args. Oh noes. The string is actually going to be like the title. And this will be 0, 1, or 2, I think maybe 3. But I run it and you'll see, oh no, this is the title. And 0 is an X. If I change that to a 1, notice it gives me the little exclamation mark I thing. If I change it to a 2, I'll get this. And I think 3 is the little green icon. If I'm not mistaken. Question mark. 4 will crash it, I think, if I remember right. There you go. Because 4, it doesn't go beyond 4 for that. Those are just the different options you can pick with the JOption pane. Like that. like that. So now you could use either or depending on what you want to do. Now that is output. Next would be, of course, variables. And we have a couple of different variables we can say. We have your integer number, and that's going to be whole number. 1, 2, 3, 4, 5, 6, 7, all the way up to 2 point something odd billion. And it can go negative 2 to 2 point something odd billion. Now, we also have float, number 2, and that would be 8.0f. And basically, this is just a decimal place. I don't use this much because we can use double. But float allows, I think it's like 7 or 8 decimal places. Whereas double allows twice that many, I think up to 15 decimal places. It's got double the precision. For what we're building, we don't really care if we're using more memory. A couple of extra doubles isn't going to kill us. If we were doing millions and billions of calculations per second, we would definitely care whether we're using a floating point or a double. But basically, decimal numbers, like 7-ish decimal places. I'll have to look it up. Decimal places. And there's always going to be that F at the end. So if I were to print, number 2, and I can just say number 2 is quotes. And I do have to have this plus here whenever I attach a variable at the end. But you'll kind of see 8.0, right? Actually, it's not showing the F, but normally in the older version it did. But that F has to be there when I'm doing this. If I take it off, it will say it's a double, not a float. So a floating point does have to have that F in it. Now, a double, number 3, 8.0, no F. And that can go up to like 15 odd spaces of decimal places. Has double precision compared to a float. All right, so those are our 3 main variables. Typically, you'll use int and double more than anything. Now, as far as numbers go, there's also short, there's also long. There's bytes and bit too, but we'll never really use those. But a short is like a really, really small number. I've never honestly used it in any kind of programming. Long is actually particularly useful. It's for numbers that are kind of greater than 2 point something billion. Your regular integer is a 32-bit int, if I'm not mistaken, and it allows up to 2 point like something billion. Once you exceed that amount, you're bigger than the integer allows. For numbers that big, you would use a long. This is used a lot when you're calculating frames per second or something like that, or ping even. Whenever you need to get, really large numbers, when you're calculating time, for example. Java has a time variable that gets you how many milliseconds have passed between now and January 1st, 1970. And it's a lot of milliseconds. But they use that, how much time has passed between now and that date. All right. Several seconds later, how much time has passed now? Do a little math and you have basically how much time has passed in that little short distance. Milliseconds, multiply it by 1,000, you got seconds. This is how games and stuff figure out ping. They get a timer and they see how many milliseconds have passed, between different commands. I pressed enter. I click on this thing, go get this guy. All right, the command goes to the server, comes back. How many milliseconds does that take? If you're playing a game and it says like, 100 milliseconds, then you're good. If you're playing a game and it says, 1,000, 5,000 milliseconds, you're not so good. Nothing's worse than telling your little character to go over here and do something and it happening like 3 seconds later. So those are those 2. We don't use them often, but you will use long. More than anything, really. As far as other things, we have character, or it's a character, so I always call it char. But I hear a lot of people use char. Up to you, really. But that's basically a letter. And it's used with a single apostrophe, A. Now this can also be 3 or a symbol. It's not quotes, but it can be anything, really, ASCII-wise. It can be that's a character, that's a character. Even a blank space is considered a character. We have, of course, string. Bilbo Baggins. And this has quotes. All right, and back to it. Bilbo Baggins would be your string. Now, a string can be anything from numbers, letters, symbols, like that. Uh, Anything I want to put into it, basically. And it can be up to like 2 million characters long, or I'm sorry, 2 billion characters long. Generally, you won't make it that big, though. So, this is most of it so far. Let's see, integer, float, double, short, long, character, string. And of course, that holds words, while this holds characters. Words, sentences, so forth, so on. We also have Boolean, and that will be either true or false. And those are our typical data types that we use, variables and things like that. A Boolean is used to, it can be used as a flag. Has something happened? Has it not happened? It can be used, what's typically what it's used for the most. Has this occurred? True. Then don't do that, or do something else, or exit out, or close. Did I click exit? True. Well, then close the program down. Of course, I can print all these variables, which, like I did up here, and I can use the JOption pane or your regular print statements to do that as well. If I want to print more than one variable, for example, like this, I can plus, add a little quote, plus, and say number, 1, for example. This is actually the part where most people end up having problems, actually. Doing a variable, doing another variable. I can put like a little plus sign there. And you kind of see it'll do a variable, then it'll do another. Like that. I had an 8 for my integer, I think, and then I had an 8.0 for my floating point. And so you see both of those gonna get displayed. If I do it this way, you'll see there's a little plus in between them. Nothing's actually happening, but I could add more. I just put a little plus here, I put more quotes, put more things. This is actually the part that people have the most difficulty with. Transitioning from quote, you have to have a plus if you add a variable. Plus, you have to have some more quotes, plus another variable. That's typically the structure that it follows. Now, that gets us through the first part. The next part would be conditional statements. Now, this would be your if statement. So if check equals true, for example, I print a little statement. Woo! I can say else. Boo! Like that. And I'll put a little comment here because it's the end of the if. And I would encourage you to do that. If you want to be a little more specific, in check equals true. I know that's supposed to be the end of this here. This if in particular. Now, if for some odd reason you have this thing badly spaced and everything, like this, and it looks really, really ugly, you can press Alt-Shift-F in NetBeans, and it will automatically line up all the braces and all that stuff for you. It's particularly useful when you're trying to figure out where you screwed up, brace-wise and stuff. So if this happens, check is true, so it would run woo, as well as all my little pop-ups. Woo! If I change this to false, then it would run boo, like that, because it's either going to be this, or if it's not that, it's going to do this. That's what an if-else does. You can, of course, have an if like so, parentheses, blah equals meh, whatever you want to put in there. And I can have an else if. Well, it helps if I do quotes. I'll just write it out. It'll be a little easier. So if check equals true. Oh, and there is a shorter way to write this, like this up here. I can say if check equals true, or I can just say if check. Because check's going to be true or false. I don't actually have to have the equals equals true. If I said, if exclamation mark check, that would be the same as saying if check does not equal true, or if check equals equals false is actually, all of these are actually equivalent. This, it just depends on how you want to write it. Zoom in so you can see that a little better. But these are the different ways you can do it when you're dealing with Boolean statements. When you're dealing with numbers, however, number 1 equals 8. And it's number 1. Notice if I get an error, it'll tell me it doesn't know what that is. Cannot find symbol means, well, it looks like it's a variable, but you haven't defined it yet because I called it number 1 and not number. There it is. And capitalization does matter, lowercase, uppercase. Now, else if number 1, and anytime you name something, by the way, you can't have a space like this. You could do an underscore, number 3, but no spaces. You also can't have a number in the front. It's got to be a letter in the front, or an underscore works even if you need to. But else if number equals, let's say 9. Number 1 equals 9. And then I'll say else, and I'll put a little end if there. Again, I know that seems tedious if you haven't done it, but trust me, it will save you a ton of time. Now, this if here, we'll basically say if number 1 is 8, do this. If number 1 is 9, do this. And if it's any other number other than those two, it'll do this. It does happen to be 8, so it'll print steak. If I change the number to 9, it'll print chicken. If I change the number to anything else other than 8 or 9, it would print salad. That's what this actually does. If, else if, else. Now and I can have as many else ifs as I want. Now as far as other ways to write this, notice that there is a yellow line here that says replace chain of ifs with switch, right? Well, I'm just going to copy and paste this so I have two versions of it. A switch statement is actually more efficient than an if, but it's basically the same thing. If I click this little icon over here, it'll say convert ifs to switch, and I'll just let it do that for me so you can see it. Like so. Now this is what a switch looks like. End switch. There we go. Now notice I have switch number 1. Number 1 is going to be the variable that I'm using for everything after this. So in this case, number 1, there you go. Case 8. This is the same as saying if number 1 equals 8. And notice I've got my steak, just like I do up here. And then I have this break, which I'll explain here in a minute. We've got if, number 1 equals 9. And then the default is basically just the else. If it's not any of these other numbers, it'll run the default. Now here's what happens. I choose 8. Let's say 9 for this example. If I choose 9, it's going to check the first in the if statement. That's false. It'll go, there's another else if, it'll check that. That's 9. It'll run that. And voila, chicken. If it was 20, it would check the first, check the second, the third, the fourth, the fifth, however many there were, until it finally got to the else and printed that, unless it found the number I was looking for. But it'll go down the list with basic ifs. The way a switch case works, however, though, is a lot more efficient. If I choose 9, for example, it won't check any other case but 9. It'll go directly to case 9, ignore everything in between, which is why it's significantly faster. Now, if you have like 100 things to check, a case statement would be vastly superior in speed. Now, you'll notice that there's this little break here. And break allows me to basically leave a brace. I can use it for loops. I can use it in if statements. I can use it in lots of different places. But if I don't have this break, notice when we have an if statement, we have these braces, right? And you can actually write these if statements without the braces, but I'm going to tell you doing that is a terrible habit, and you're going to screw up if you do that. It's much better to have the braces. Because this brace here, I can see clearly what code is in here. Now we just have a single line, but imagine if there were 50 lines. I'll see someone write an if like this, and I'm like, no. I mean, this will run the very next line, and if there's a line after that, it'll run that. If there happens to be any space anywhere, that's where that if statement ends. It's kind of ambiguous. Now, if you put some braces in there, it is very clear where this if begins and ends. That's why I tell people always put your braces and mark them too. It makes it significantly easier. Now for the switch, there aren't braces. So if it hits case 8, it's going to print this, and what it's actually going to do is move on to the next case, move on to the next case. It'll actually print all the cases, unless I tell it to stop somehow. And how I tell it to stop is this break statement. Exit out of the switch. Basically what this break does is tells it to go here. And I can use this in loops and other things too. If it's time to end the loop, break and it'll leave the loop. That's another way you can actually get out of a loop. But those are your two if statements. Now we have if and we have switch case. Now further on, there is compound ifs, which is if, let's say number 1 equals 8, and number 2 equals 8.0, f. That's a compound if. What this is going to do is, if it's an and, both of these have to be true. If it's an or, either or can be true in this case. And you can have as many of these as you want. I can say this and this and this and this. A good example of this would be, let's say, tic-tac-toe. If the first slot has an X, and if the second slot and the third slot all have X's, you've won the game, right? If there are 3 in a row. That's where I would have to use something like that. I'm just going to do that. Nested ifs. If number 1, equals 0. Inside there, I write if number 2 equals 8.0, f. This is what's called a nested if. Now, these can basically perform the exact same function. It just depends on how it's written. The difference is, in this case, if the first one is false, then it's not really going to bother with any of these others. It's going to stop and just not run it. If this first one happens to be true, it will actually go in here and run any code you have before it checks this if you have it set up that way. So you can actually do a little bit more with the nested than you can with the compound, but compound is a lot less writing a lot of the time, and it's a lot less convoluted. It depends. Sometimes it's better to do it this way. Other times it's better to do it that way, depending on what program you're writing and how you're doing it. And we also have loops. There are 3 major kinds of loops that you typically see. The first one would be your for loop, which is one of the easiest. For int I equals 0, I less than 5, I plus plus, like that. And I'll write end for there. If you want to be more specific, end for int I, you could write out the whole thing if you want, and I can just print a little message. Let's go with hamburger. So what this loop's going to do, after I get through all my little pop-ups and stuff, is print hamburger 5 times. Now the problem with loops is you have to think, as Doc Brown from Back to the Future always said, fourth dimensionally. This thing's going to print, and over time it's going to do some other stuff. So in this case, we start off at 0, and to illustrate this a little better, I'm going to add a little plus I here. And you'll see 0, 1, 2, 3, 4. It's printing I every time it runs. So I is 0. It's going to say hamburger 0. And this loop's going to get here. It's going to come back up here, and it's going to check. After every loop, I goes up by 1. That's what I++ is. I++ is the same as I equals I plus 1. You can also say I plus equals 1. And that adds 1 to I as well. So those are 2 or 3 different ways you can actually kind of do the same thing here. Like this. Plus equals is actually very useful when you want to add, let's say, 2 to something, or 3, or 4. You could also do the same thing here, like that, but like so. Plus plus just adds 1 to it, so it's kind of the easiest thing to write. Now, it'll say, all right, this is 1. Is 1 less than 5? Yes. We're going to go here, print. Now it goes up by 1. It's 2. Is 2 less than 5? Print. Is 3 less than 5? Yes. Is 4 less than 5? Yes. And then it's going to go up again. It's going to be 5. Is 5 less than 5? No. That's where it stops. Now if I put in less than or equal to, then it will go one more. It'll go to 5. So it depends on how you have it written. Now, if I were to do this, for example, let's say I minus minus, I would have what's called an infinite loop. And it will go on for all of eternity. Well, actually, not all of eternity, since I'm printing a variable. It'll go until negative 2 billion or so, and then it'll crash. But I'm not about to wait for that, so I just have to hit stop right there, and it'll stop. A for loop is very hard to make an infinite loop. It's possible, but the way it's designed is a for loop is for, I want to loop this many times. And in this case, you know how many times that is, and that's what this is used for. If I want to do 10, well then I change that to 10. If I don't know what it's going to be until the program starts, I would make a variable, and then that would be the variable instead. I don't necessarily have to use I could use other variables and stuff if I wanted to. I could start at 1 instead, and this would be hamburger 1, 2, 3, 4. So there's a couple different ways you can do it. While loop, while. Now, I'm going to do basically the same thing. Int I equals 0, I less than, oh wait, nope, there we go. While I is less than 5. Now, it's very common, error-wise, for somebody to do this. And if you do this, basically, this loop will end. You got to have your braces afterwards. And while. And I'll just print off French fries. And I'm going to go I++. Now, it allows me to do I here. Notice that I have I up here. And it's allowing I here. Why do you think that is? Pause the video and think on that for a second. Why can I do I in both of these places? Normally, if I come up here and I have, like, in this case, double number 3, and I say, well, double number 3 equals 8, it's going to give me this little error saying variable 3 is already defined. I can't define it again. Now, I can come up here and, there we go. I can say number 3 equals, in this case, 9.9. I can change it. but I'm not going to be able to define it again. This right here is defining it, telling Java to make this variable and set it aside so I can use it. I'm going to call it number 3. So I can change, but I can't redefine it again. Now, if you look here, I have my for int I equals 0, and int I is there. I'm using it, it's printing it. And then I have int I again, and it's not complaining. Now, the reason it's not complaining is because I exist. Oh, stupid headset keeps cutting off. I exist only inside this for loop. So once this for loop is done, I is thrown away. Because notice it's inside. It's basically inside these braces here. So I can print I all I want. Once this loop ends, I does not exist anymore. Now, since I've defined it here, though, it does exist. So when I run this, I'll get French fries and hamburgers like that. But if I try to use int I again, it's going to give me an error because I've already defined it outside, basically. This is what's called scope. Not to be confused with the scope of a gun or the mouthwash. Basically, it's where you define stuff matters. So if I define something inside here, int num equals 8, then inside this loop, once I make it past this line, I can print num, right? I can even come down here and say num plus equals 10, and that should make num 18, right? If I run this, what should I get printed? French fries 8, 8, 8, 8, 8. Notice it's not going up by 10. And the reason it's not going up by 10, because here's what happens. This loop goes, I is 0, 0 is less than 5. I create a number, 8. I print 8. Now number goes up by 10, it's 18. I increase I. The loop comes back up here. I is declared above it, so it still exists. It's going to be 1 because I just increased it by 1. We're going to come back here. We're going to redefine number again. It's 8. I print 8. I increase it by 10. It's 18. I come here. And when I come back up, I've thrown all this away. It's gone. So this number only exists the one time I go through this loop. If I did it inside of an if statement or something, it would only exist inside that if statement. That's what scope means, basically. If I define it all the way up here at the top of the main, then it can be used inside any if statement, inside any loop, inside the main. Now, if I define it all the way up here, I have what's called a global variable. That means anywhere in my program, I can use that variable. But there are some stipulations with declaring stuff up there, and some issues too, which we'll go over later. Now I'm going to use do while, and I'm just going to say I equals 0. I'm going to use the same variable. I'm going to say do, and in this case, I'll just say chicken tenders, while I is less than 5, and I'm going to say I plus plus. This is the third loop. We have for, while, and do while. Honestly, these are the two that I use the most of. I don't use the do while that often, but that's kind of the gist of it. This goes a certain number of times. A while loop can go a certain number of times, which is what I've set it for, but it can also go goes a certain number of times, or until something is true, false. Until something happens, you can go. So this actually is a lot more versatile than just that. This is basically go 20 times. This can be go 20 times, but it can also be a lot more. So it's a bit more advanced. Do while is exactly the same as this, except for one thing. Let's say I make this a 6 before this even starts. Well, 6 is not less than 5. This whole loop fails. In a do while, it's going to do this code first, and then it's going to check it at the end. So the way a do while works is it will run at least one time, no matter what. So this is useful if you, like, let's say, had a game and you're like, pick one of these games. And at the end, do you want to go again? Sure. Then, change the variable so they can loop back up and pick another game. If you want them to run at least once, then this is probably the better way to go. Though honestly, I just use these two. Now there's also nested loops, which would be a for loop inside of a for loop, for example. Orient I equals, well, I can't use I. J equals 0, j less than 5, j plus plus. Now, for those who may ask why I'm using I and j, it's just specifically because in old school programming, a lot of these other letters were reserved for other things. And the first one that really wasn't was I. So historically, whenever anyone's taught programming, any kind of programming, you go back, you see loops. Almost always they use IJK for their loops and stuff. It can be anything. I could make this, Bob if I want, and that'd be perfectly acceptable. That's just historically how it is. For int k equals 0, k less than 5, k plus plus, and I can have a loop inside that loop. And all I'm going to do is just simply print a little statement here, woo, and inside here I'll print, let's do /t, which is tab, no, and I'll run. And you'll note, oh, whoops. If you notice, I told you it's very hard to make a for loop an infinite loop, but if you do something dumb, J, you can do it. So no matter how skilled you are, you're going to screw up somewhere. So this will print woo, and then notice no is 5 times. So the first one is 0, then it prints this 5 times. Then it comes back up, j is 1, it prints this 5 times. So whenever you have nested loops, this would be basically 5 times 5. I'll get 25 total no's if you count them. That's kind of how nested loops work. Now you can have a nested while. I'm not going to write it, but it would basically just be the same thing, a while inside of a while. And that's the basics of most of what we covered in Java 1. I'll do the methods in another file or another video since we're getting pretty long here. If you have any questions, you can comment down below, ask questions. You can message me directly if you feel like it. Anything and everything. Hopefully that gets everybody caught up with most of what we did in the first class. We still have a little bit more to go over in the next video, but that should kind of get you the foundational stuff that you need to practice on if you're having some trouble with it.